In today's video, we're going to be creating and interpreting lines of best fit of scatter plots. So in this first example, it says a company has developed a diet plan that includes exercising. They would like to study the association between the number of hours spent exercising and the weight loss due to the diet. They have 50 test subjects that follow the diet, as well as record the number of hours they spent exercising over a 3-week period. The scatter plot below shows the results for the 50 participants along with the line of best fit. So in part A, it says, what does the line of best fit predict the weight loss of a person who exercised 14 hours? So we take a look where 14 hours exercise is on my x-axis. It's right here. Okay, that's 14. So we look up and get to our line of best fit from that 14, and we see we have this point right here, which is about 11 pounds. 11 pounds lost. Okay. It says estimate the y-intercept given the line of best fit. Given interpretation of the y-intercept with the context of the problem. Okay, I would say this is not. It doesn't. So the y-intercept is right around here. It's not exactly 2. It's a little bit higher than 2. So I'm going to say it's 2.3. So the y-intercept is about 2.3. And what does that mean? Okay, if a person doesn't exercise, their total weight loss is 2.3 pounds. So a person who doesn't exercise loses about 2.3 pounds. Part C says circle 2 points that the line of best fit passes through and write their coordinates in a table, and they don't have to be actual points. So that means these points right here are actual points, the ones I'm kind of highlighting. They don't have to be those points. They just have to fall nicely on the grid lines. Let's see some points that fall nicely on the grid lines. I would say definitely this point right here and this point right here. All right, so what are those points? Those points are 6, 6, okay, and then I would say this point right here, that point right there, is about 9, 8. All right, so those 2 points are in the table. Find the slope of the line that passes through those points. Okay, so remember slope is rise over run. So this goes up 2 over 3. Or you could have done that in the graph, up 2 over 3. Bam. Now, it says express your answer as a decimal rounded to the nearest tenth. So 2 over 3 as the decimal is 0.6 repeating. So when I round that up to the nearest tenth, it's going to round up to 0.7. Ugly 7, there we go. Using proper units, interpret the slope. So as the time increases by 1 hour of exercising, the rise of our line of best fit is going to increase by 0.7. So 0.7 pounds are lost every 1 hour exercise, or 1 hour exercising. So as it goes up 0.7, it goes to the right point, or just 1, not 0.1. Write an equation line of best fit in y equals mx plus b form and use it to predict the weight loss of a person exercises for 12 hours. So remember, hours exercises is my x, so we would take that number and plug it in for x. But let's first write our y equals mx plus b equation. We have our slope, we have our intercept, so our equation is y equals 0.7x plus 2.3. Now we plug in that 12 in for x. So you have 0.7 times 12 plus 23, or 2.3, excuse me. 2.3. So that is going to be, I'm going to do this in the calculator, 0.7 times 12 plus 2.3. So they're going to lose about 10.7 pounds. Okay, so using the skills we learned from linear functions, we're creating our line of best fit and interpreting the slope, the intercept, and applying those to solving equations. Okay, and the rest of these problems have more to deal with those kind of same scenarios, just with different graphs. All right, so that's it for today's video. If you have questions in class, please let me know. Thank you for watching.